A vast number of human beings can attest to the fact that the computer has changed the world, and today things run in a completely different way. It has taken position in every arena of human life, and has at some point turned out efficient than man. Workplaces, homes and processing companies depend on the gadgets for day-to-day chores. The computer's work is based on calculating the input and delivering a corresponding report. The input is translated into binary text, which is translated in commands for the semiconductors, like transistors, which tell whether the current should be higher or lower than 1 volt. Using the pulses, every calculation is done. Also, the X and Y coordinate system is calculated so that the computer can know how each pixel should be colored, thus create the display.
The Internet stores an immense portion of human knowledge and is available to the free world for access. Besides wide-range research and information, it also entails niceties that give life color and make it worthwhile. Entertainment, shopping, news and communication which has no distance with the system. The Internet stores an immense portion of human knowledge and is available to the free world for access. The mechanic of the Internet is simple. Data, or everything we see on the Internet, is stored in servers all around the world. A server is a very big and powerful computer that can contain a lot of data and calculate with it. When we go online, we just connect with the server and we work with the data in it. The traditional touchscreen technology is analog resistive. Electrical resistance refers to how easily electricity can pass through a material. These panels work by detecting how much the resistance to current changes when a point is touched. This process is accomplished by having 2 separate layers. Typically, the bottom layer is made of glass, and the top layer is a plastic film. When you push down on the film, it makes contact with the glass and completes the circuit. The glass and plastic film are each covered with a grid of electrical conductors. These can be fine metal wires, but more often they are made of a thin film of transparent conductor material. When you press down on the touch screen, contact is made between the grid on the glass and the grid on the film. The voltage of the circuit is measured, and the X and Y coordinates of the touch position is calculated based on the amount of resistance at the point of contact.
First created in Malibu, California by Theodore H. Myman in 1960, the lasers have since been termed a solution looking for a problem. Consumer electronics, information technology, science, medicine, industry, law enforcement, and the military have been positively affected by lasers through the years. Having revolutionized surgery in the medical field, sight can easily be restored by use of these devices. A laser creates light by special actions involving a material called an optical gain medium. Energy is put into this material using an energy pump. This can be electricity, another light source, or some other source of energy. The energy makes the material go into what is called an excited state. This means the electrons in the material have extra energy, and after a bit of time they will lose that energy. When they lose the energy, they will release a photon, a particle of light. The type of optical gain medium used will change what color, wavelength, will be produced. Holography is a technique that creates 3D images called holograms. To create holograms you need a laser, lenses, and a beam splitter, mirrors, and holographic film. Holographic film can record light at a very high resolution, which is necessary for creating a hologram. The difference between holographic and photographic film is that holographic film has to be able to record very small changes in light, even microscopic. A beam splitter is a device that uses mirrors and prisms to split one beam of light into 2 beams. The process of creating a hologram. 1. The laser points at the beam splitter, which divides the beam of light into 2 parts. 2. Mirrors direct the paths of these 2 beams so that they hit their intended targets. 3. Each of the 2 beams passes through a diverging lens and becomes a wide swath of light rather than a narrow beam. 4. One beam, the object beam, reflects off of the object and onto the photographic emulsion. 5. The other beam, the reference beam, hits the emulsion without reflecting off of anything other than a mirror. A scanner in terms of computing is a device that optically scans images, printed text, also handwriting, or an object, and makes a converted digital image. Types of scanners. In offices there are variations of the desktop flatbed scanner, where the document is placed on a glass surface for scanning. Handheld scanners, where the device is moved by hand. They have evolved from text scanning ones to 3D scanners used for industrial design, reverse engineering, test and measurement, gaming, and other applications. Mechanically driven scanners that move the document are typically used for large format documents, texts, where a flatbed design would be quite impractical. Modern scanners use a charge-coupled device, CCD, or a contact image sensor, CIS, as the image sensor. On the other hand, drum scanners, which are developed earlier and still used for the highest possible image quality, use a photomultiplier tube, PMT, as the image sensor. There is also a rotary scanner, used for high-speed document scanning, which is a type of drum scanner that uses a CCD selection instead of a photomultiplier. Non-contact planetary scanners are essentially used for photographing delicate books and documents. All these scanners give us two-dimensional images of subjects that are usually flat, but sometimes possibly solid, whereas 3D scanners produce information on the three-dimensional structure of solid objects. Digital cameras can be used for the same purposes as previously mentioned scanners. When compared to a true scanner, a camera image is subject to a certain degree of distortion, reflections, shadows, low contrast, and blur due to camera shake. Resolution is sufficient for less demanding applications. Digital cameras are better for speed, portability, and non-contact digitizing of thick documents without damaging the book.